Lesson 2.4, parallel lines cut by a transversal. Before we were just talking about regular lines cut by transversals. Now we're talking about parallel lines cut by transversals. Are you with me? Good. Today's objective is for you, the student, to be able to find the measure of angles in parallel lines cut by a transversal. That's all you got to do. So first, let's do a little bit of a review. What's a parallel line? All right, what is it? What's a parallel line? Now, you might have heard it. You probably have some idea of it. Let's just remind you. Parallel lines that are always the same distance apart, all right? And this is the part you probably remember. And never, pause, write it. Okay, check it. They never intersect. They don't? Ever. Forever. So what would that look like? Well, it would probably look something like this. You got this one. Nope, let's make it nice and straight. You got this guy. Look how straight and beautiful that is. And this guy, right? And look at these two lines. They're always the same distance apart, and if they go on forever and ever and ever and ever and ever and ever and ever, they'll never intersect. Now let's take a look at these two lines. We got this guy and this guy. All right? Now they're not intersecting, right? But if this line kept going and this line kept going, they would intersect. And just to show you that I'm right, which I always am, boom. Boom, look at them intersecting. Bad, that is not okay. Let's pull that back a little bit because I know your age or yours. All right, that is non-parallel lines. Same distance apart, don't forget that part, and they never intersect. So there's a few facts that we know, and these facts are facts. All right, feel me? If parallel lines are cut by transversal, we know a few things are true. We know that alternate interior angles are always congruent. All right? And this is only when you have parallel lines cut by a transversal. So the symbol that we use for parallel, by the way, you need to start getting used to this. If you know two lines are parallel, there's these little triangles like this that tell you that they're parallel. All right? So now I know that if I call this line M and line L and M, these two are parallel. And a little more information for you, the way we would state that they're parallel, we would say L is parallel to M. That's the parallel symbol. All right. So alternate interior angles. Remember, that's like this guy and this guy. These are on alternate sides on the interior. These would always be congruent. So if this is 70 degrees, I know that the opposite, the alternate interior angle of that would also be 70. These two would be 70. Alternate exterior angles are also always congruent. All right, believe it or not, they're always congruent. So let's take a look. You have this angle and this angle. All right, these are alternate exterior angles, and because they're alternate exterior angles, they're always going to be congruent. So if this was, say, 60 degrees, that's what it looks like to me. The alternate exterior one's going to be congruent, and that's only if these two lines are parallel. All right. Now, does that even look true? Look, this angle looks exactly the same as this angle if you take a look at them. And this angle looks exactly the same as this angle because these are alternate exterior angles and they are therefore congruent. Corresponding angles, guess what? Also congruent. All right. So, example corresponding, top left-hand side, top left-hand side. These are corresponding angles. And so if this was, let's say, I don't know, 55 degrees, we know this would also be 55 degrees because corresponding angles are congruent when the lines parallel. All right. And then finally, same side interior. Same side interior angles are congruent? Not really. Let's take a look at this case right over here, okay? If we look at same side interior angles, and let's make it a little more extreme, okay? Do these two angles look congruent? This angle and this angle? This one's small, that one's big, this is acute, this is obtuse. Nope, they are not congruent. These two angles, same side interior angles, are always supplementary. All right? These two are supplementary. And if you already forgot that lesson, let's put a little side note. They add up to 180 degrees. All right? So this angle and this angle always add up to 180. So if this was 100 degrees, this guy would be 80. Same side interior, always. Supplementary. All right, so how are we going to use this information to solve some problems? Well, there's a little system I like to use, all right? And the system goes like this. If I wanted to find out what the measure of angle 1 was, the first thing I would decide was I would find the name of these angle pairs. So 66 and angle 1, what kind of angles are these? Well, they're on the same side, in the same position. This is top right, this is top right. So these are corresponding angles, all right? That's my first step, just recognizing. Corresponding angles. Now I'm going to write if they're congruent or supplementary. I want to know what their relationship is. And I know corresponding angles are always congruent. If I forget, just go to the front page and look it up. From that lets me know what the angle 1 must be. And if these two are always congruent, I know this is 66 degrees. So angle 1 is equal to 66 degrees. Solved it. Boom. Angle 2. I want to find the measure of angle 2 in this case. Now, once again, we're just going to use the same steps. We're going to write the name of these angle pairs. So we got this angle and this angle. That's the information we have. All right. These are on the interior, if you remember. Look, these are in the interior. Boom. And they're on the same side. So these are same side interior angles. Same side interior. Now I know same side interior angles are supplementary. Just look it up. It's a fact. So my equation would look something like this. 50 degrees, right, plus angle 2 is going to be equal to 180 degrees. I want to find out what angle 2 is, so I'm going to drop a line down here. I got to subtract 50 from both sides. All right. And I get angle 2 is equal to 130 degrees. Boom. And, you know, I always like to see if this stuff makes sense or I'm just saying things. Let's see. If angle 2 was 130 degrees, would 130 and 50 be supplementary? Sure thing. That's 180 degrees. Did it right. Now, finally, we're going to solve for x. The steps don't change. What we're going to do is first identify our angle pair. We got this guy and this guy. They're on the interior and on opposite sides, so these are alternate interior angles. Interior angles. I just learned that alternate interior angles are always congruent. And so what I can say is I can set these equal to each other, because congruent means the same measure, the same length, same size. So 4x minus 10 is going to be equal to 58, right? Because these are congruent angles. They're going to be equal. So I'm just going to solve this. Drop my line down. All right. Once again, I'm going to put variables over here because I have a variable, numbers over here. So I got to move my 10 over. Move my 10. I'm just doing a little solving. Do it on your own. You could pause the video, check if you get it right. This cancels. I get 4x is equal to 58 plus 10. That's 68. Do a little division. Divide by 4, and we get x is equal to 17. Boom, bang, bing. Did it. Now, I always like to check my answer, so let's see if this works. Now, this angle is 4x minus 10, right? And this has to be equal to 58 degrees, right? Because they have to be congruent. Let's plug in x. 4 times 17 minus 10 should equal 58 if I want these to be congruent angles. 4 times 17 is 68 minus 10, which is equal to 58 degrees. And sure enough, 58 degrees is equal to 58 degrees. And I did this one right. Smiley frickin' face. Look how happy he is. All right. Now, let's use this information now to solve two more problems. One, with just one angle, all right, we could fill in every single one of these angles with what we've learned about angles, angle pairs in this unit. I'm going to show you how, okay? So let's just use everything we know. Well, let's start over here on this top part. If I know this is 50, then I know this angle over here is also 50 degrees, right? Why? Because they're vertical angles, and vertical angles are always congruent. So that helps me with that. Vertical angles. Now don't forget now, if you look at these two angles, right, these two angles, that's a linear pair, this angle and this angle. So I could do 180 minus 50, and that gives me 130 degrees, right? This has to be 130 degrees. Now let me get all this craziness. Write that down, but let me get that craziness out. So we know this is 50 because they're vertical angles, all right? And we knew that this is 130 degrees, right? Now if I know this is 130, I know this is 130 degrees because these are also vertical angles. Now let's keep going with this. This 50, all right, can be brought down over here. This is 50 degrees because these two are alternate interior angles, right? They're on the interior, they're on opposite sides. Now I know this is going to be 130 degrees. Once again, because these are alternate interior angles. Now if this is 50, then I know this is 50. Oh, let's do it in blue to keep it consistent. Because these are vertical angles, and once again I can use this 130 to give me 130 over here because these are vertical angles. So that's how you could fill in all these angles if you just knew one. Vertical angles, linear pairs, alternate interior, all that stuff helps me fill in all the angles here, and it all makes sense. Alright, so let's give this challenge problem a shot. Now you'll see why it's so challenging in a second. If angle BDC is 2x, alright, and DGF is x plus 42, what is the measure of DFG? So let's start filling in some stuff. BDC, which is up here, is 2x. Alright. And we know that DGF, which is this angle right here, is equal to x plus 42. 42. The first thing we're going to have to do is write the name of the angle pair. And the crazy thing is here, well, let's go through them. Let's see what angle pair this is. Are these alternate interior angles? Well, let's see. Well, they're not both on the interior, so they're not alternate interior, though they are alternate. Are they alternate exterior? Well, they're not both on the exterior, so they can't be alternate exterior. Are they corresponding angles? Well, one's on the left, top left, and one's on the top right, so that's not the same position, so they're not corresponding. And are they same side interior? Well, this isn't on the interior, so they can't be same side interior. So crap. So what you can say, oh, what happened over here? Okay, maybe I cut a little. So I'm going to just say that there's no relationship here. None. Okay, fine. I am going to say none. So there's no relationship. Yes, I could spell none. What I can do, though, is outsmart this question still. So if I know this is 2x, I could also say that this angle over here is 2x because these are vertical angles. So this angle, GDE, that is, what's it called? That's 2x also because these are vertical. I could do that. That's true. These are congruent. Now if you look at these two, these are same side interior angles. And I know these two angles will be supplementary. Alright? So I just proved this. Because these two are vertical and these two are same side interior, I know that these have to be supplementary. Now from here, what I'm going to do is set up my equation. So since these are supplementary, I could say that 2x plus x plus 42 is equal to 180. Alright, just one more time, remember you have two angles and they add up to 180. It's 2x plus the whole thing, x plus 42 equals 180. Now how do I solve this? Well, you do the same thing as always. You draw your line down the middle, alright? You put your variables on one side, numbers on the other. So this is our number side and the variables are here. So what we're first going to start by doing is moving our numbers over. So we're going to subtract 42 from both sides. The numbers have to go on the number side. That goes away. My 2x comes down and my x comes down, and that's going to be equal to 138. Now if you look over here, these are both variables and they're on my variable side. So I'm just going to combine them. So 2x plus x equals 3x, and 3x is equal to 138. Now I ran out of room, so let's keep solving over here. 3x is equal to 138. To solve, I'm going to divide both sides by 3, and I get x is equal to, what is that, 36. Cool, did it. Now, I'm not done because if you look at the original question, I want to find the measure of DGF. Now, if I want to find the angle, and a lot of people have asked this, what I do is first solve for x, and then I have to plug it in. So that's my second step. Now that I found x is 36, I can't forget to plug this in. So DGF isn't 36, I got to plug in here. So 2x plus 42 is what DGF is equal to. Sorry, we changed this question. Don't write that down. This is x plus 42, all right? So this is 36. We plug our 36 in. 36 plus 42 is 78. And so we know DGF is equal to 78 degrees. That's that for this lesson, guys. Remember, whenever you go to a movie, put your phone on silent because don't be that guy.